Chapter 2, Section 2 discusses the scientific method. Now, I'm sure you've heard about the scientific method before. Our book breaks it down into kind of 5 basic steps. The order of the steps is not necessarily the important thing or what they're called. It's mainly that you do an experiment in a logical fashion that's the important part. The first thing that generally starts out the scientific method is the observation. Okay, that's generally when people see something out in nature, they're like, why did that happen? And that's what leads them to forming their hypothesis, which is a testable explanation of their observations. So the key to a hypothesis is that it needs to be a testable statement. One of the ways to make it very easy to ensure that you've got a testable statement is to phrase it in an if-then statement. If I do this, then this will happen. Okay? Again, by phrasing it that way, it ensures that you have set up your hypothesis in a way that clarifies what variables you have and that you can easily test it. Once you've made your hypothesis, your prediction of what you think is going to be happening, you can then perform your test or your experiment. When at all possible, we like to run a controlled experiment where we have a control group and an experimental group. And that is not always possible in science, but if we can, we like to do that. By having a control group, you can then compare the results from your experimental group to your control group to see how accurate you were and to kind of ensure the validity of your results. Once you have completed a test, you've collected your data and interpreted it, you then will either support or refute your hypothesis. If your data supports your hypothesis, you might conduct the experiment again. You might have other people conduct the experiment again before you would move on to the theory state. If your data refutes your hypothesis, well then perhaps you'd like to revise your hypothesis and try again. Or maybe you want to tweak your experiment and retry that same hypothesis. So you can kind of go back and restart this process or make changes as needed. Once an experiment has been done many times and you've got the same results and other people have replicated this experience and also gotten the same results, that is when you can form a theory. Now in science, a theory is a well-tested explanation of observations. It's not just a random idea of why you think something has happened. It actually has to be very well tested, and it's going to explain why something occurs. So the hypothesis predicts, the theory is going to explain why. And then finally, you could publish your results. And there's many reasons why someone might want to publish their results. It could be to share their information with other people so that they can have their experiment replicated to form a theory. It might simply be to try to reach a conclusion faster by collaborating and sharing with others. So there's many reasons why someone might want to publish their results. A scientific law is going to be a description of the natural world that is proven reliable over time. So, as opposed to the theory, which will explain why something happens, the law is describing what's going on. So, for instance, the law of conservation of mass, we've done an experiment on this. That tells us that mass is neither created nor destroyed. So it's simply describing what's happening. Mass, we're not creating it, and we're not destroying it. Okay? A theory would explain why that would happen.